Oh, this is in the bottom of my hamper for a month. I can do that. Whatever. Just saying. Yeah, pull me a little lot warmer. Okay.
Did you fit into these platforms? Are these the ones?
These are small ones. Those. Here's my nails. Come here.
A little bit. Ooh. How does that calculator taste? You don't want to leave it behind, I'm sure. Oh, really make fun.
They're not that much fun, really. It's a trap.
Let's go jump. Let's go jump, sweetheart.
Goodbye.
Bye-bye.
See you in a bit. Peace.
Door. Yep.
Thank you.
Okay, sweet. Sorry. I don't know why I was struggling to get in, guys. Oh, come on.
Hello. Hi guys. Sorry I was late.
You good, dude?
So are there really only 2 more weeks of classes after this?
Something like that.
That's
That's-
insane.
I think there's 3.
Yeah.
Oh yeah, 3. Yeah. Because there's 13 in total, right?
Something like that.
All right. All right. Has everybody done the homework that was due tomorrow? Because I haven't started that yet.
I haven't done that
I did it.
Okay.
I've done today or lesson 3, but I haven't done lesson 4.
Okay. Well, let's see. Oh, no, this, okay. Question 1's from, I've already done that stuff. Let's see if I can
yet. Yeah.
find where to do it. Somewhere.
Wasn't there a problem like extremely similar to this?
Yeah.
Yeah.
It was like super simple. Oh yeah, good.
Okay, let's go.
Do all of your calculators do maximums and minimums for you?
I think mine does. I couldn't really tell you how to do it, but okay, let's see. How do you do this? Okay. First.
I'm sorry that I'm kind of eating and doing this at the same time.
Gotta make sure you bring enough for everybody.
Yeah, you gonna share, man? Come on.
I would.
Okay. So there's the partials, and then plug in. Okay.
Great.
Who knows?
Wow. Duh.
All right. Has anybody finished? Jessica, you finished with the first part? Sorry.
Yeah.
What'd you get for
I got 2 over the square root of 17, 3 over the square root of 17, and 2 over square root of 17.
Really?
Yeah, I got something different. Yeah.
I got 1 over the square root of 3 for all 3 parts.
Really?
So, Jessica, I'm close. So I got 2 square roots of 17 over 17, 2 square roots of 17 over 17, and then 3 square roots of 17 over 17. So I think, well.
So, okay, so
I think all I did was I brought the radical up. Was it?
well, you said that because I have 3 over square root of 17 being in the y.
Oh, see, I got that as the Z.
Z.
So let me look back and see if I did something wrong.
What did I do wrong? What do you guys have as your equation?
What?
What's y'all's like starting equation? I don't know what I did wrong.
So you do the partial derivatives of them, right? Oh, what's your starting equation like for F?
Yes.
Oh, my problem gives me 3 ln of xy plus 3 ln of yz plus ln of xz.
That explains so much.
At one
I have a different problem.
I have a different one too, Jessica.
Ah.
So
Okay.
I got
Okay.
ln of xy plus 3 ln yz plus 3 ln xz.
Man. Okay, let me double check. Let me go back.
Does anybody have the same one as me?
I do not.
So nobody does. Do we? So none of us have the same problem.
What is Jessica's?
Mine's 3 ln xy plus 3 ln yz plus ln xz.
Mine's different.
Yeah, me
Ah.
and
I just
Jessica just swapped a 3. So
I just have 2's in front of every one of my LNs. So they
I
like,
have 4 LN, then 3 LN, and then 1 LN.
wow. I'm sorry.
Okay, okay.
I think me and Jessica are, well, because we just swapped a 3, right, Jessica?
Yeah.
I think that's the only thing different. So I think me and you have the same answer. I just brought the radical up, essentially, because you had 2 over square root of 17, 3 over square root of 17, and then 2 over square root of 17, right?
Yeah, so I think you just rationalize the denominator, right?
Yeah, that's all I did.
So then whatever we get for our vector u, the vector negative u is just, we change the sign on all of those components, right?
Correct. Yep. So it would just be negative all those. And then the third part, all you do is take whatever you had in the denominator, or
For the magnitude.
the magnitude, right? Isn't that all it is?
The magnitude and then negative magnitude.
Yeah. So the third part would be the positive magnitude, and the fourth part would be the negative magnitude. Correct?
Yeah.
Okay. Cool. That's what I thought. See, this one, I mean, these problems make sense. Don't ask me like what the function of knowing this is, but like I understand how to do it, like how it's broken down, but I don't necessarily understand like what the purpose of it is, but I don't know. These ones weren't too bad. Shoot.
Is anyone on number 2?
I'm working on number 2.
What's your function?
X cubed plus y cubed plus 6x squared minus 9y squared minus 8.
You have 6x squared?
Yes.
Okay, I have 3x squared, but everything else is the same. Do you remember what we do when 2 x values and 2 y values, when we set the first partial derivatives equal to 0? Like, do we equal 0 and -2 and y equals 0 and 6? For the points, do I like just mix and match them? Like, do I make 0, 0, 0, 6, -2, 0, -2, 6?
Did you get 2 x values or 1 x value?
Values and 2 y values.
You got 2 y values? So, for example, like you could have got like x equals 2 and then y equals plus minus 1.
Because my equations were just like 3x squared plus 6x equals 0 and 3y squared minus 18y equals 0.
Okay. So,
Ones I got x equals 0 and -2 and y equals 0 and 6.
How do you solve those again? Really, like I'm totally drawing a blank. When you have like 3x squared plus 12x equals 0, how do you get x?
You factor out what's in common. So you factor out like a 3x or something,
Okay.
whatever the common multiple is. And then you just set that equal to 0, and then what's left in your parentheses equal to 0.
Okay. So if 3x equals 0 and x plus 4 equals 0, so I get x equals 0 and I get x equals minus 4. So you had 3y squared minus 18y, right?
Yeah.
Okay, so you factor out a 3y and you get y minus 6 equals 0.
Uh-huh.
So then you have a y equals 0 and a y equals plus 6.
Yeah.
Yeah, so you have to turn that into 4 critical points.
Sounds good.
Really quick, so I haven't done the homework yet for these. So is it you take the partial derivative and then you have two equations, and then you take a second derivative of those, and then
So you only
Um,
well, you do have to take the second, but to get the critical points, you just take the first and set those to 0.
okay. Oh,
And then when you're looking for min, max, and saddle points, then you have to use the second partials test.
so for where it's like how it's asking for a local maximum, you just have to take the first root. Is that what you're saying? Or are you saying
No, so you have to actually figure out what type of critical point they are, you have to use the second. But you use the first to find your critical points.
that's right. That's right. That's right. Okay. Okay.
So does anybody have x cubed plus y cubed plus 6x squared minus 9y squared minus 8?
I don't.
I don't.
Okay. So we're all going to have slightly different everything. This entire.
Yeah.
Yeah, it looks like that. That's good. What's your equation?
Mine is x cubed plus y cubed plus 3x squared minus 9y squared minus 8.
Dang it. Our first three were the same, but the last two weren't. Mine is x cubed plus y cubed plus 3x squared minus 3y squared minus 3. So, but he's a little bit
Is yours
different.
different, Sawyer?
It is, ma'am.
Oh.
Yeah, so 3x. Okay, and then let's do one.
Jessica,
Uh-huh.
how do you solve for fxy? And where does that come from?
Wait, say that again?
So, like, for the second partial test, how do you solve for that d value or whatever you call it?
Oh, the Hessian. There we go. That is, so the first row of your matrix, you're going to have the partial derivative of your first component of gradient f,
Okay.
or the partial derivative, and then in the first row, second column, you're going to have that derivative with respect to x of the second component in your first partial. And then the second row is your y derivatives.
Okay. So how do you get that second, say that second part again. Not
So-
the x derivative or the y derivative, but the other one. Okay.
So you take
so,
the
hmm.
So you take the x derivative of both of the components of the first partial, and
Okay.
that will be your row 1.
Okay.
And then you do the y derivative of both the components of the first partial, and that'll be row 2.
Okay. And did you get 0 for all that?
No, I got 6x plus 6, 0, 0, and 6y minus 18.
Okay.
So I think like ours should be the same except for the top left-hand corner, because you have different a different x squared than I do in the original. But I think the other 3 entries should be the same.
So I just want you guys to know, I can use Wolfram Alpha, and I can just type in local max of and local min of and put in the formula, and it actually gives me results and tells me where.
Really?
So if you want to check you do
That's
that
awesome.
on your phone. You can get that on your computer, just so you know you can use it, but it's actually honestly a little easier on my phone. But yeah,
Nice.
so
That's good to know.
So if you have a 0 in one of your points, it seems like the
Uh-huh.
test has to be inconclusive. But that shouldn't be right.
Oh. Well, because, all right, so when you take the derivative of the 3y squared minus 18y in terms of x, that is going to be 0 because there's no x terms, right?
Yeah. And same with the other way.
Yeah, I don't. Let me go back. If either largest or smallest eigenvalue is 0, then the test fails. So the eigenvalues have to equal 0, not the partials.
Can I ask you guys something really quick?
But don't both of ours equal 0? Oh wait,
For the
not the partial.
yeah, those are the partial. The eigenvalues are like the little lambda sign.
Can I ask you guys something really quick?
Uh-huh.
So when you guys are doing your the first partial derivatives, and you solve them for your 2 values, right? Like you get 2 values for x and 2 values for y. One value is 0 and one value is another number.
Uh-huh.
How do you know? I feel like this is a really stupid question, so I'm sorry. How do you know which point goes with each?
You have to make 4 points. So like 0 would go with both 0 and then the other. And then your non-zero value of x would have to go with 0 on the y, and then also with the non-zero y.
Okay. And so then do you test each coordinate? And that's what you're saying, you test each coordinate.
Yep.
Okay.
Yep.
Test each one of the second derivative test, and that's where you do how is the second derivative test set up? I'm sorry to be asking so many questions today.
The second derivative, so you're going to get a 2x2 matrix,
Okay.
right? For the second derivative, or the second partial. Did you get that part?
So you take the partial of each one you had. So you take the partial of the one with x in it and the partial one with y in it.
Right.
And that yeah. So which one goes where? Because like
The x partials go in the first row. The y partials go in the second row.
wait, you get two partials?
Yeah, so the second derivative should be a 2 by 2 matrix. So like you're going to take the derivative of your first partial derivative in terms of x, and then you're going to take the derivative of your first partial derivative in terms of y. And since there's two components of the first partial, you're going to get 4 outputs.
Oh, and so you're saying that so this one of those partial derivatives is going to be 0, right?
Yeah.
Okay, for each one. Okay, that's where I was confused. I was like, am I supposed to be getting that? Like I feel like I'm okay. That makes a smash. So I'm pretty sure the Wolfram Alpha works, by the way, because I got 2 of the points that it gave me back.
Nice.
I haven't tested, but so if you guys want me to test your equations, just tell me.
I used it as well, and like I got the points that I came up with, but I got them all different, as different things. So I probably made a mistake.
Oh, you got them at different like locations?
Yeah, it gave me like the min and max different, and I had one of the other ones as a saddle, but
Oh,
sure it's me.
Wait a minute. That's supposed to be a negative 18.
Jessica, I'm so sorry you have a cold or whatever you have.
Oh, it's okay. Sorry, I probably sound awful.
It's okay. I can hear it. I'm just like, oh my gosh, I feel so sorry.
Oh, it's good.
So is it normal for a saddle point to not be at one of those critical points we just calculated?
They should be at. Is Wolfram Alpha telling you that you've got a critical point somewhere that we didn't find?
No. So when I go to Wolfram and I put in critical, it gives me the exact same 4 points that I got.
Right.
And I change it to solve for saddle instead of critical, and it's a 5th point. It's totally different. So
Oh, that's weird.
I thought it was supposed to be at one of the critical points.
Yeah. I don't know.
I haven't. Never mind. How did you put in your singleton? What did you put in for it? Like in Wolfram Alpha to check?
Say that again. I couldn't quite hear you.
Oh, it's for Brady.
Yeah.
Oh, okay.
How did you type in your like saddle point thing in Wolfram Alpha?
So are you at the little thing where it says input fxy and you put in the equation?
Yeah.
And then it asks you like if you want to solve for like local or max.
I think I just got it.
Because I just went out and Googled and it crit and saddle.
Yeah. I just got it. So the one it gave me are 2 points. It actually gave me 2 points for a saddle, where a saddle occurs, and they're both at points that I found, I guess.
So I can just do critical. If I just type in critical point or Wolfram, Okay.
Be right back.
X to the third plus the third x squared. Critical. Negative 4, 0, 0, 0, 0, 6, and negative 4, 6. Will you try mine, Sawyer, and see what it gives you for a saddle point? Can you guys hear me?
Yeah, you said you wanted someone to put in that to.
Sawyer left.
Oh, I'm back. Sorry, I'm
Oh,
not.
all right. Yeah, I was wondering if you test mine and see what it gives you for a critical or for a saddle point.
Okay, give me 1 sec. Like work clothes. Sweatshirt. Don't want to be revealing to you guys over the cam. Okay. All right. What's your equation?
I have x cubed plus y cubed plus 6x squared minus 9y squared minus 8.
And did you want me to look for critical points or the saddle point?
Saddle.
So I got 0, 0, and negative 4, 6.
So 2 saddle points?
Yeah,
That's what I got on when I did my calculations.
Okay.
I got 2 saddle points on mine as well.
Okay, that's weird because mine gives me all the critical points that I got, and then it does not give me that for a saddle.
I am using mine on my phone. I don't know if that.
Do you pay for that?
No, you just have to pay once. It's just an app. Like,
Just buy it.
$9.99, totally worth it. I bought it last time I was at school. Awesome.
There's one like, have you ever seen, I think it's called Photo Solver. Have you seen that one?
I heard about it. I think my friends.
Photo math, but
You just take a picture and it solves it. You don't even have to
Yeah.
type it in.
that's cool.
Okay, so where are we all at?
I finished with my number 2, but would Sawyer or whoever's got that app, would you mind typing in my equation so I can see if my critical points are right?
Absolutely. Yeah, let me have it.
It is the same as Brady's, except for instead of 6x squared, I have 3x squared.
You're gonna go through like every part.
So just, I guess. Wait, what?
Do you want me to like type in every part and tell you what it gives me back for each, like the local minimum, maximum, and the saddle point, or do you just want me to look at the critical?
Sure. Is that a lot of work on your end?
No, it's typing.
Okay, then sure. Yeah.
Yeah, it's not hard at all. So for the local maxima, whatever you want to say,
Uh-huh.
it is -4, and it occurs at -2, 0.
Okay.
And then
Sweet.
is at -116, and it's
Okay.
at the point 0.06.
Sweet.
So I got the saddle point to be at 0, 0 and negative 2, 6.
Yep, that's what I got. Thank you.
Hayden, do you want me to check yours again?
Yeah. Why don't you go ahead? I guess I'll have you do that real quick. Let me grab this real fast. Okay, my equation. Is that what you that's how you've been checking it, is just with the original equation, the whole thing?
Yeah.
Okay, yeah. X cubed plus y cubed plus 3x squared minus 3y squared minus 3.
What's the very last part you said?
Minus 3.
So I got x squared plus y, or x cubed plus y cubed plus 3x squared minus 3y squared minus 3.
Yep.
So the saddle point, I'm going to start at the end.
Yeah, what's the saddle point?
So the saddle point is 0, 0 and negative 2, 2.
Okay. I got the negative 2, 2. I didn't realize. I guess the 0, 0 makes sense, though. Okay.
And then are you ready for the local minima?
Yeah, what's the max? Or, yeah, whichever first.
Okay. The local minima, negative 7, and it's at the point 0, 2.
0, 2. Oh, okay. I guess I'm just doing that backwards. So it's at 0, 2, and it's 7, right?
Negative 7. Okay, hold on. Let me go back and look. Yeah, so it's negative 7, and it's at the point 0, 2.
0, 2. Okay. And then what's the max?
It is. The maximum is 1, and it's at negative 2, 0.
Negative 2, 0. Okay. All right, man.
This app has come in handy so many times in my life. I got it last year.
So it actually solves the values for you as well?
Yeah, it gave me everything. I just, hang on, where's local max of, and then the equation. Local min, and then I just did saddle point of. I guess y'all are already on 3, aren't you?
I did 3.
Can I ask, is that from homework or lesson 4?
It is. It's the very last thing.
Yeah, so I don't know how to do that.
So
Do you take like a partial derivative or
what's your equation?
x squared plus y squared plus z squared equals 1, and then t equals 1100 xyz squared.
Yeah.
So yours is a sphere, and it's the x squared?
Yeah.
Yeah, so you have to, so one of your equations is considered your constraint equation, and that's the one that has an equal sign. And you have to take both partials of it. And then the other equation is your optimizing equation. And you just have to take the partials of it. And so then there's a formula.
Is this the Lagrange thing?
What's that?
Is it the function minus lambda g, where g is the constraint?
Yes.
Oh, okay. So which is my constraint? Is it the t equation?
No, your constraint always has an equal sign in it, in the actual equation. So it's the x squared plus y squared plus z squared equals 1.
You
That's
mean
our
it's
constraint.
equal to something? Because my t is equal to something as well.
Yeah, that's just a function that you're trying to optimize. Like if that said like 1000 xyz squared equals 9 or something, it's going to change.
Okay,
It's
so
dependent
you're
on
saying
the other one.
that it's equal to.
Yeah.
Okay. So
Also, this is really annoying. So I programmed my calculator to solve them. So I can just I should be able to just run your numbers and check them. If I'm doing them right, I end up with like 10 critical points that you have to evaluate, and it's really annoying.
you.
In fact, mine has 6, 7, 8, 9, 10. 16.
Jeez.
Ugh.
Yeah. Okay, so really, you were kind of cutting out the first time you told her how to do it. So I know like which one is my constraint, and I have t equals 1000 xyz squared. And so, yeah, I don't know how to solve these. What do you?
Okay, so that's your optimizing. So the optimizing one, you need to first off take the partial of it.
And that's the t equals 1000 xyz squared.
Yeah.
Okay, so partial derivative for every single variable, right? For x, y, and z. Okay, so after you do that,
So you can write like what was your partial for x in your optimized equation? What's your partial for x?
1000 yz squared.
Okay, so you can set that to equal lambda 2x.
Y2x.
Because that's the partial, or no, sorry, the partial of the other one. Yeah, the partial of the other one, right?
Oh, okay, I didn't take
In
that.
terms of x.
Okay. And then, am I solving for, what am I solving for?
So now also do that with your other terms. So you can set like your partial of y is to equal lambda of your other partial of y.
You said is the lambda y or lambda minus that?
It's times.
Is it right? Okay.
Could you guys see my screen if I tried to show some notes?
I'm sorry. What
Yeah, let me click on
I wonder if
screen
you
share
can.
thing. Okay, so I just presented to everyone, so hopefully we all see you.
I see.
I was just gonna hold something up to the camera. Is what I meant.
Oh, okay.
So can you? Yeah. Can you all see my camera?
Yeah, just let it focus in for a second. Hold on.
I don't know if I can get it to focus.
Move it. Yeah, move it back just a little bit.
Which way?
Towards you. come on.
So this was a really easy one where my optimizing equation out of the homework was just xy.
No, don't move. Don't move.
How about I just take a picture of it and put it on my screen and then share my screen?
Okay.
So I don't have to sit on the
We're all like staring at the screen.
Yeah.
Breathing in the camera.
Or I can just run them through the calculator and give you guys the answers. But
So you solved for lambda though? Is that what you were doing right there?
yeah, so you're gonna have two terms with lambda in it, and then you can solve.
How long did the homework take you?
After I got tired of doing them and started using my calculator, like the first one always takes me like 2 hours, you know, and then they only take like, I don't know. It seems like you can do every problem in about 10 minutes. Okay, so what do I need to do to share my screen now?
You go to the green picture of the computer with the arrow in your upper left hand corner of your Google video thingy.
Yeah.
Nope, that's not what I wanted to share. Let's try that again. How do I stop sharing? Can you see my screen?
Okay.
What do you see?
I see black.
Yeah, I see it.
Why did it? How about that?
Oh, that's so tasty. That's awesome.
Yep.
So you can see my constraint equation is the 4x squared plus 3y squared equals 1.
Uh-huh.
And then it said the other equation was just like fxy equals xy. So I took the partials, and they're just right under each equation. And then I used that formula where I set the dx equals lambda, the other dx. So that's my y equals lambda 8x. And I did that with the y partials. So x equals lambda 6y. Then I solved both of those in terms of lambda. And now lambda equals y over 8x and lambda equals x over 6y. So I can set those two equations equal.
So it doesn't matter which, we have 3 variables in this equation. It doesn't matter which two we use, right?
Say that again.
Like we have 3 variables in this equation.
No, it's the same idea.
Yeah.
That's why this one has it's a pain. You're gonna end up with like 16 critical points. I ended up with 4 in this one. So once you have you set your lambdas equal right here, I just kind of cross multiplied to come up with these two equations. So if that guy is the same as that guy, right? Just divided both sides by
Okay.
2. Now once I got down to just 3y squared equals 4x squared. If those two are equal, you can go back to your original constraint equation right here. Those two things are equal. And it has to equal 1. So that's the same thing as 4x squared plus 4x squared equals 1. So I turned it into that. And then I was able to solve for all my points.
We do need to do this. So we need to do the part where you set the lambda equal to each other. We have to do that twice.
That's like the easiest way from what I found. There wasn't a problem in the homework nearly as hard as this one on the quiz.
Mhm.
The one on the homework you'll have to do is like a volume of a cylinder or something. So you have to use like remember in like Calc 1 you did a lot of optimizations of volumes. You'll kind of be doing that. Anyway, so I don't really know what the best way about going and getting all every one of the critical points is. It's really annoying.
Okay, so let's see here.
I'm going to quit sharing. That's the process. Now you just have to make it work in something really annoying.
Oh man, I love that screen.
Okay, am I still sharing? Like, stop sharing. Okay, thank you. I don't know if I could have done that somewhere.
Yeah, that problem's brutal. Jeez.
Um,
Can't find my quiz. Oh, there it is.
If you find out what you are, and
What's that?
you can put them back into the original equation, so I found that x squared is equal to y squared, and that 2y squared is equal to z squared. So I can plug everything back into the original equation just with y's. What do I do after that?
Yeah.
After I have one variable in the original equation. Hey Brady.
Yeah, go ahead.
So after I have like all the same variables in the original equation, what do I do after that?
So you have all the same variables as what?
In like the original equation, like so I just have like y's in the original equation. Like when you were saying you had x squared plus y squared plus z squared equals 1, right? Or if you heard that one. So like after I get so after I just get it down to one variable in there, like what do I do after that?
So you have something like x squared equals a number?
Yeah.
So
So
that's your x point then.
and I just so I have to take the square root of it, which gives you 2 points, and you just have to do that for every single variable.
Yeah, so you have to do that for every variable to get every x, y, and z. And then, so let's say you have 2 x points and 2 y points and 2 z points. You're going to end up with like 32 combinations.
That's really obnoxious.
Or 16. I don't know.
I don't agree with that. Nope. Oh, wow.
Man, that's brutal. I got some random answer. I might just plug it in and just try it. I don't know.
I can show you guys. Well, I don't know. I have notes on how to do this exact problem with a different number. None of us have 900 XYZ, right?
No. Wait, 1100 or 900?
900.
Oh, no.
I don't know. Actually, it's like 3 pages long to solve this problem.
That's just wrong.
Hey, I just looked it up on Chegg.
Yeah, does Chegg have the one with 1,000? Because I looked at the one that had 900.
No, it doesn't have that. It has the one with 400. Here, let me try.
Okay, it also had. Yeah, I saw the one with 400.
You know what? So I get the same answers as that. So I would think I would get the same critical points. Like I got X is equal to plus or minus Y, which is equal to plus or minus 1/2 for Z. So I think I should get the same critical points, which is a bunch. Maybe I'll just plug in and see if I get.
Wonder if he gets the same thing. How similar they are
So-
when they do the 900 and 400.
Okay, so I'm getting the maximum is 100 degrees. And so then my negative would be, or my minimum would be negative 100 degrees. So I might just try that. I don't know. I was on the same track, so I got the right variables as the one in Chegg. So I just used the same critical points that they have there and then just plugged it into my own equation. I plugged it into 800 XYZ squared. So I don't know.
Isn't. Wait. Technically, if we're looking for the highest and lowest temperature, doesn't
Correct.
that mean you really only have to check? Like yes, you have all those points, but since all of them are just plus and minuses of each other, you just put in the positives of everything. And for the lowest temperature, you just put in the negative.
I think so. I mean, that's essentially what they're doing in Chegg here. They're not doing anything
Right.
fancy. He found a bunch of critical points and then just plugged in the positive, essentially, of all of them.
Yep. Yeah. Okay.
I can do it now.
Yeah, I think I'm just going to go with that.
What answers did you get? Do you want me to run yours through my calculator and see if it's? Because I actually just found mine on Chegg with with exactly
Okay.
the answers that my calculator gives.
It gives the same. Yeah, run mine and see if it's the same.
Okay.
Excuse me.
What's your problem?
Ready?
So the first part's the same. X squared plus Y squared plus Z squared equals 1.
Okay.
And then T equals 800 X, Y, Z squared.
Okay. Now this literally takes my calculator about 3 minutes.
Jeez, that's crazy.
So it says busy right now. I'll tell you when it's done.
Okay, cool.
Hey, Brady.
Yeah.
What numbers did you have?
1,000 XYZ squared,
Oh my gosh, that's what I have. What two numbers did you get?
0 and negative 125.
Okay, so I got. So I got 125, but I got it as positive. I wonder what I did wrong. 0
2,
and negative 125?
what's that?
0 and negative 125?
Yeah, as the lowest.
And the highest wait, what was the highest temperature then?
0.
Yeah, okay. I'm saying I thought you were saying both of those were the lowest, and I was like, what?
No.
Okay. So I got that. But I don't,
Okay, so um, so my calculator gives me, oh, still thinking, a 0 and 100.
Well, I mean, I got 100, and then for the minimum, but for the minimum, I got negative 100.
Okay, it's still solving more.
Oh, okay.
Let's see if it ever does a, yep, there's a negative 100. So it does show negative 100 to positive 100.
Okay. I think I'm going to go with that.
I'm confused now on if mine is supposed to be, Sawyer, did you think yours is negative 125 all the way to 125?
yeah, that's kind of what I was thinking, but
It might be. I need to run mine again. I might have wrote it down wrong.
okay.
Dang it.
Because I
What
think
number is yours, Jessica?
Well, you see, I'm still trying to get all my critical points.
Okay.
So I don't know. I've got 8 so far, but I think I'm supposed to have like 16. So I'm having
It
a
might
hard
just
time.
be 8.
It might just be 8.
Yeah, I think it is.
Okay.
Well, I don't know. My calculator spits out more than 8, but Chegg, everybody on Chegg is just listing 8.
Oh. Okay.
I don't know why.
2 times 2 times 2. Yeah, so that makes sense because the combinations, there's 2 x's, 2 z's, and 2 y's. So 2 times 2 times 2 is 8. Okay.
Well, I just submitted, and that was right for mine, Brady. So
Okay.
I think that should work. I got to go take a quiz, but I think that last one, I think you're on the right track with that. And then the stuff on Chegg, I just kind of basically followed along and then submitted in the points into my equation. So
I'm pretty sure like it has to be the positive and negative of itself or whatever.
I would totally think so.
Basically, in one
yeah.
instance, all of the numbers are positive. And so you're getting the largest number. Then in the other instance, one of the numbers you're plugging in is negative, so it causes the answer.
Right, exactly.
So all the 10 points, it's just going to be the negative of itself.
Hey,
Well, at least I'll know when I go to do the homework tomorrow. I'll at least be on the right track, I think. So
Yeah.
Hey Sawyer, could you run my local maxima and minima through Wolfram again and solve for those
Dude,
values?
Yeah, I'd love to. Hold on one sec.
I just want to make sure that I can stick numbers back into an equation and correctly.
So you had, what was your formula?
X cubed plus y cubed plus 6x squared minus 9y squared minus 8.
Whoa. Hold on. So you had x cubed plus y cubed plus 6x squared minus 3y squared minus 8.
It's minus 9y squared.
Oh. 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 All right. Minus 9y squared. Okay. So the maximum I got was 24, and it was at the negative 4, 0.
Okay.
And the local min was negative 116
Okay.
at 0, 6. And then the saddle point was negative 8 and negative 84, and they were at the points 0, 0 and negative 4, 6.
Sweet.
Okay.
Oh. Rats.
So do you want me just to run yours, Jessica, and then you can go through the homework? It'll
Yeah,
be
sure,
a
that'd be great.
It'd be a lot better for you, I think, because this one's a lot harder, but
Okay.
it'll. So what is
Yeah,
T equation?
1100 xyz squared.
Okay. Now we gotta wait like 6 minutes.
Okay.
all right. Well, I missed a portion of the first problem, but all of our problems are different. So okay, I think
Did anyone get like 100 on their quiz?
on week what?
On what quiz?
Quiz?
Sorry, you cut out again. Week 9 or what?
Yeah, 9.
Okay, let me look. I've been emailing him back and forth all week, fighting with over quiz 8. I don't really.
Yeah, I did. Yeah, I did do so hot on week 9. So no, unfortunately.
I don't know what
On that week 8's homework, I derived one of the equations that he wanted us to just start with,
Uh-huh.
and then like you got an answer of like t equals 3, and then your feet was like 166 feet or something.
Uh-huh.
My time, I got 2.99 instead of 3. I got 2.99. You marked it wrong, and so then when I
Oh,
distance by 2.99 seconds instead of 3, I was like a couple inches. I was 165.9 or something, and it was supposed to be like 166. And he marked that wrong, and he will not correct it.
ridiculous.
interesting.
So
Why would you not? That's so ridiculous. Why would you not correct that?
yeah, I don't know. I'm done with him. He was like, after we emailed like 4 times today, and he's like, maybe you should just call me. I'm like, nah, I'm done. So on the week 9 quiz, I got a B.
Okay. I got an A minus.
Which one did you miss?
That I got. I missed 5B.
1B.
Did anyone get that one right?
Sorry, I didn't hear which one.
5B.
5B. What did you get?
So I wasn't really sure. So I ended up doing the integral of let's see. I did the integral of f of r of t times the magnitude of r prime of t, 11.244.
So yeah, I did. What did you get for? I guess in 5A, you got 4y sine x plus x squared cosine y.
Yeah.
Okay. So then I did the integral of f TDS, like you said. So I just evaluated it at the points 3, 1, and 1, 0.
Wait, what? 3, 1, and 1, 0?
Yeah. And those come from your time bounds there.
Time bound. Like the r of t?
Yeah, so I put 0 in for t.
So you don't integrate it from 0 to 1.
I did not know. How many points did you get on it?
5B, I got 0 points.
Okay, so I got 6 out of 9 on that one. So I put t into the 2 squared plus 1, and I get a point, and then I put in the square root of t, and I get a point. And then I put 1 in each of those, and those are my two bounds that I integrated from. So I integrated from 3, 1 and 1, 0.
On the original f equation?
Yeah, on the 4y sine x plus x squared cosine y,
Oh.
and then, yeah.
Okay. So,
Well, I guess you don't have to integrate it again because we already did up above. But those are the points I put in for x and y.
So
so what did you learn wrong on yours?
I had a -1 on the end of it, and he gave me. So I don't know if I made a mistake in just my algebra when I solved for my points, but I got 4 sine 3 plus 9 cosine 1 minus 1, and he circled the -1. So maybe I need to go through and reevaluate.
Huh.
So I just realized that I have week 9 quiz on my computer, but I didn't upload it and submit it. So that's awesome.
Oh, no. I'm so sorry.
Okay, I don't even know how that happened. You guys started talking about it. I'm like, oh, I'll go look, see what I got. And there wasn't anything. It said overdue, and I was like, what? Oh, how does that happen, guys? What even? That's so. Dang it. Oh, I'm so sad.
See what he says.
Yeah, I think like in the syllabus it says you get like
You guys-
percent docked each day. I accidentally turned mine in like 6 hours after it was due, and I wasn't marked down at all on it.
Wait, hang on. Say that again. I'm sorry, you cut out.
On one of my quizzes, I turned it in 6 hours after it was due. Like I forgot to turn it in, and he didn't mark me down on it.
Oh, really? Okay. Well, maybe I just emailed him. Like, can I still turn it in? I'm so sorry. I'll have to. I can't believe it.
So did that
Um.
the thing, Brady?
Yeah, so I got 137.5.
The highest temperature and then negative 137.5 for the lowest.
Yep.
Okay. Great, that's what I was getting.
Can I ask you guys a question about number 4 though on question 9 or quiz 9? I know I'm gonna get it wrong. I honestly, I just got confused on like I feel like I think I forgot just how to find the potential with that little photos. I know you like take the partial derivative of each of like the f equation, right, for x and y, and then like something that appears twice you like don't use. I can't remember.
The ones that appear twice, you only use once.
Use once. Okay. So after you do that, so what do you do after that? So like, for instance, like what was the equation I guess you got?
I got 10x minus 3x squared y plus 4y squared.
Okay, so 10x minus. Okay, so that's what I got too. Awesome. So what? So it's so funny. So I did it once where I had that, and then I like was thinking that I didn't do it right, and so I like left out the 3x squared y.
Well, I got that one right, so you do, I think you do keep in the negative 3x squared y.
No, yeah, I totally trust that you do. So after, what do you do after that? I just got that.
That's your answer.
Like that's it?
That's your potential, yeah.
Are you serious? It's just that equation. That's all.
Yep. Uh-huh.
What? Why? Holy cow, guys! Struggled this week, I don't even know what's going on. I like sat there for literally an hour on that question. I was thinking I had to do something else. I'm like, what is going on?
That's the
Holy
worst, man.
cow. What in the world? Okay. Well, all right then. I guess that's kind of a good thing because that means I wasn't as completely confused as I thought I was. Like I tried to go back and find that, and I just like could not. I was like, what in the world was I supposed to do? Okay. That's great. What did you get for number 3? What was your answer?
I got 16 pi squared plus 12 pi.
So that's what I got, and he took off half my points because I only showed the work up to the integral.
Oh,
And
wow.
then I stuck the integral in my
That's
36, which we are allowed to do.
huh.
So you got, you got 16 pi squared plus 12 pi?
Wow. Yeah.
Okay, whoops. I got minus 4 pi for some reason.
I think I ended up getting that first, and then like I realized I calculated something wrong.
Yeah, I just saw that too. I was supposed to have a plus 8 pi, and I had a negative 8 pi.
Yeah, that's the one I missed when I first did it.
Okay, thank you.
Yep.
I find it very surprising how much he takes off.
It's ridiculous.
Like even if you do all the, because I show all my work, I do all my work on paper, and like even still, if I just mess up something like that, it's still like half the bomb are gone. I'm just like, holy cow, dude! Like
I've got C's on the last 2 quizzes, and I have all the right answers.
that's insane.
But once I get to an integral that I can stick in my little handheld, I stop.
Right.
That's crazy.
So did you do number? Hey Jessica,
Which
did you do number 6?
I did A, and then I emailed him about the curl because like on my summary page I like had one thing about curl, and so I'm like, I don't really know if we're supposed to know that yet. So then he's like, okay, I'll email the class about stuff.
I did it.
A,
I did it before I did the quiz like a week ago, and
oh really?
So I got answers, but he didn't mark them right or wrong. So I'm kind of curious. I just wanted to know if I did them right.
Oh.
But-
A.
Hey,
Gradient of f. It's a vector. I put it in vector form. Y cosine x minus 2z squared. Sine of x, comma, and then minus 4zx.
That's what I got too.
And
And
he
he,
wrote
like,
question marks right over top of that. I don't really know. It's like I'm totally not on the same page as this guy.
Yeah. Huh. So can I ask how you did the curl of 6b? Like, because like I know the curl is like the cross product of f and the gradient.
Yeah. So it's like DC. I just said like my ddx equals a and my dy equals b and dc equals c, just to make it easy, because the formula for curl is like dc dy minus db dz. There's just a formula like dA dz minus dB dx or whatever it is.
But what's your other vector besides the gradient vector?
It is is it the original equation? Where do I have? I can't even read my own handwriting. It's dc. So dc dy, I put 0. dB dz, I put 0. dA. And I don't know if I even did it right.
hey, Jessica.
Oh,
Uh-huh.
I don't know. I don't know what I did for the vector.
So I was like, because of my confusion on number 4,
Okay,
I'm
I
also
see.
like, very confused about number 5 because that's for the potential on that one. So where it says show how to find a potential for this gradient field, what did you do? Because I don't know if I did it right.
I put down of 4y cosine x plus 2x cosine y dx, and then the integral of 4 sine x minus x squared sine y dy. And then I just took those, and then
And that's all?
yeah.
Okay, so I did that, but then I wasn't. So I was like, I spent like another hour on that one because I was like really again confused. I thought there was more I had to do, and so I just sat there and like stared at it, and I was like, but okay, cool. So I wrote that down, so I don't. Hopefully, he'll give me points for it. For number 9, what did you do there? For number 5, part B. Sorry, not number 9. I'm looking at the.
So I got that one wrong. I didn't get any points on that one. And I found like the integral of like f of t times the magnitude of r prime, which I guess is completely wrong. So I would
So you have your r vector there, right?
yeah.
So just
Yeah.
take your time bounds and put 0 in for your t's, and you get the 0.10. And then you
Okay.
put time 1 into your other t's, and you get the 0.31.
Okay.
So then I just evaluated from the equation we solved above, the 4y sine x plus x squared cosine y. I just evaluated that from 1, 0 to 3, 1.
Oh,
Value. Take the integral of it.
No, because we already took the integral up above.
Oh.
oh,
Oh.
oh. Look at that guy. He's so smart.
But I missed like 3 out of 6 on it, or 3 out of 9. I need to check and see if I just messed up my. Yeah, I don't know what I did.
I did really quick. 12 sine of. Wait. Wait a minute. Sine of 1?
That doesn't work.
Sine
Oh,
of 1 is...
that's a decimal. See, that's something that's actually that threw me off because that like messed me up because I remember I tried to take the derivative of or like I tried to take the sine of like something like that and it really screwed me over because I was like, that's like an insanely complicated decimal. What am I supposed to do?
So what are you looking at?
I'm evaluating the thing, and when you plug in 3, 1, you get 12 times sine of 1. Did you like write the decimal, or did you just leave it as sine 1?
So I didn't get sine 1. I got sine 3, and I just left it as sine 3.
Oh, sine 3. Yeah. I'm plugging it in wrong.
Oh, yeah. And so then on the lower bound, sine 1, yes, I did leave that as sine 1. But that ends up getting multiplied by 0 on that bound.
Okay.
Can I ask you guys something else that's like really random? I just want to know if I did it right.
Uh-huh.
Wait, what is cosine of 0? Isn't
So
that...
you know,
1.
there's this. Yeah, it's 1. You know,
Okay,
like,
so that's why I put in minus 1, because I ended up with my lower bound equaling cosine of 0. So I wrote that as minus 1. Huh. Let's see what you guys get.
9 times.
so you guys know like gives you the equation like it. So in that problem in part B, it gives you the equation, the integral of f dot t ds, right? So when it has t right there, is that referring to like the velocity vector over the magnitude of velocity vector, or in other words, r prime over the magnitude of r prime?
I think so.
Well, so you know ds is equal to r prime dt, right?
ds, I think, is that the magnitude of r prime
Yeah. So it was,
dt? Or
yeah. R prime magnitude of r prime dt. Did I say that wrong? So I was
I think you just said r prime, but yeah, I get the gist.
okay. Cool. Yes. Well, thank you for correcting me. So when I was looking at that, it kind of made me. Doesn't that mean so if you have f dot t ds, which is really f dot t magnitude of r prime dt, couldn't the r primes like cancel out because they multiplied by each other, they right by each other, and then you would just have. Does that make sense
Yeah,
what I'm
so
saying?
you would just have like the force vector dot the vector.
Like just the original. Does that make sense? Like, could you just do the integral of the force dot the r vector dt?
Maybe. I think you should be able to.
Does that make sense? Like I wrote that through that algebra on the paper, and I was like, doesn't that work? But I don't know if it does or not.
Huh.
I don't see what's wrong.
Along the curve. Yeah, I don't know. So
I can't tell what's wrong with mine either. I swear all mine are right. He just doesn't like me.
Dude, some of these questions blow me away. But
Well, see, I took this class actually last semester from Brother Rose, the guy that like writes this course, and like if you notice that test, it said Brother Rose's test, or the last quiz did or something.
yeah.
Yep.
Yeah, it was a test.
Yeah, it was the test. It was the same one we did last semester.
oh, really?
Oh.
Like, and they're both brutal. Like I failed his class even though I felt like I could do it.
Right.
Like,
So
oh, go ahead.
oh no, I was just gonna ask a question on so 9b, you got 4 sine 3 plus 9 cosine 1 minus 1.
Yeah, and he circled the 1 and marked me down 3 points.
Huh. Oh, it's minus. Wait, no. Never mind.
It should be your upper minus your lower, right?
Yeah. Huh. Okay. Sorry, you could continue saying what you were saying.
I don't remember what I was gonna say. Totally forgot.
Sorry.
No, it was.
Did anyone need help on?
What?
On quiz 8, did anyone need to go over any of that?
Um,
Oh, I
no,
think-
all the rest of my points are for like. Well, actually, I missed number 2.
Actually, I think
What
I
did you
might-
get for 2?
On quiz 8?
No, on quiz 9. Oh, sorry, I didn't hear that you asked about quiz
Oh.
8.
Oh, on quiz 9, I got 59 over 7.
Wait a second. You got what?
59 over 7.
Huh. Okay, I got a little different there. I wonder.
I think I'm pretty sure I messed up. Quiz 8. I'm pretty sure I didn't do too well on that one.
Hey, really quick, I didn't know how to do number 1 on this quiz.
Okay.
Um,
1A or
yeah.
B or both?
No, on the actual group quiz we were doing tonight. I still haven't submitted
Oh.
that.
I haven't submitted it yet. I need to.
If I have 4 LN plus 3 LN plus 1 LN, what did you guys think my first answer was going to be?
Let's see this here. So,
Right.
so what I don't know. So what I did is I just took the partial of each of them, and I just used that Symbol Lab partial,
Yeah.
or or whatever, and then you just plug in your X, Y, and Z for each of those. So then you get your values for your vector. So like my vector. So I did the partials of each of them. Mine was 4 over X, 4 over Y, and 6 over Z. And then I plugged in, my point was at 1, 1, 1. So I just plugged in 1 for each of those. So I get 4, 4, and 6. And that becomes my vector, 4I plus 4J plus 4K. And then I take the magnitude of that vector, and then you divide by it. So basically you find a unit vector. And that gives you each of your points, and that should be the first, that'll be your answer for the first part. And then the second part, you just flip the signs for all of yours. So mine, they were just all negative because they were all positive to begin with.
Okay.
And then the third and fourth one, I thought it was just the magnitude, but I missed both the third and fourth part. So I don't know what I did wrong, but
It should be the magnitude because I got 100% on the quiz.
yeah. So I don't know what I'm messed up on that, but yeah, apparently I missed something.
On question 3, was anyone else's temperatures decimals?
Was yours?
Yours was the only one that came out on my calculator as having decimals.
Because that's what I got too when I put it in my calculator. But like, I don't know if I should put the answer as a decimal or as a improper fraction.
Does it say exact answer, or what does it say?
It says simplify your answer.
Oh, man, I don't know. These quizzes are weird too. I swear we'll type in the right answer sometimes, and it's not.
But at least yours is like it's just a 0.5 for the
Yeah.
answer. It's still an exact answer.
That's
True.
true. Okay, I'm just gonna put it.
Hey, Sawyer, could you help me do number 1 on the quiz?
Yeah. Sorry.
Yay.
Did it work, Jessica?
Yep, I got 100.
Good job. So,
Well, I might jet if you guys work on that. I got to go take another quiz. So for
Okay.
my strengths class. So.
Yeah, if you guys don't mind, I wouldn't mind taking a couple minutes and try to get my number 1 right.
yeah, that's done.
Okay. Sounds good, guys.
Thanks.
ya.
so-
Bye.
Good job.
So the parameterization of 1, right?
Say that again.
Could you say it again, Jessica? I think we missed you.
Yeah, you're cutting out.
Oh, she's really cutting out.
Is she frozen again? Yeah, she is.
She's like getting there.
Green is like frozen.
Hang on. Struggling a little bit. Can you rejoin us, please? So basically, man, you want to take, so you take the partial
Can
derivative.
you hear me?
Yes, you can.
Yep.
Holy cow.
That's awesome. Okay, so I got the partials. I just do the partials of my original terms, right?
Yeah, so you do the partials of your original terms.
Okay.
And then after that, you want to plug in your number, like your point you were given, into each of those.
Okay.
So you have like a vector of just numbers, right?
Yeah, and all of those are just going to be whole numbers, right? Because we're just putting something over 1.
Yeah, exactly. Yeah. And so, yeah, so you should just have something over 1. And then after you get that guy, then just take the magnitude of that one.
Okay. And so if my numbers are 4, 3, and 1, my magnitude is 5, right? It's square root. Oh, wait. I need to add the 1 as well.
Yeah, that's a little different.
So it's 16 plus 9 plus 1. So it's square root of 26.
Yeah.
And so that's the direction, right? So my direction is like
Can
5.
you guys still hear me?
We kind of can, but you're really jumpy.
Should we just start a new call?
We probably should. Jessica, if you want to start a new call, we'll be down for that.